Hey algebra fans, Mrs. Lindsay here. Come to talk to you about real-world systems of linear equations. Is there a best method? Let's find out. In this problem, meal tickets at the circus cost $4 for children and $12 for adults. If 15 meal tickets were bought for a total of $140, how many children, X, and how many adults, Y, bought meal tickets? In this problem, it's easiest to use two equations and two variables. First, because they asked you to use X for the number of children's tickets and Y for the number of adult tickets. They also gave you a very nice pre-labeled graph with children's tickets and adults' tickets on the X and Y axis. But mostly because we're talking about two different types of data: cost and number of tickets. To write the first equation, we're going to look at the fact that the tickets cost $4 for children, and there are X children. So our total cost for children is 4X, 4 times the number of children tickets. The adult tickets cost $12, and there are Y adults. So the total cost for the adults are 12Y, 12 times the number of adults. That should give you a total of $140. 4X plus 12Y equals 140. Now the second equation may seem a little bit difficult to find because it's hidden within the word problem. But if you look closely, it says there are 15 meal tickets total. That's the number of meal tickets. Since there are two types of tickets being sold, children's, X, and adults, Y, if we add the number of children plus the number of adults, we should get the total number of meal tickets, 15. Notice how this equation deals strictly with numbers, where the first equation dealt strictly with money. Keep your money together and keep your numbers together, and you won't go wrong. Now, in order to graph these equations, I'm going to rewrite them in slope-intercept form. In other words, y equals mx plus b. So the first equation, I'm going to solve for y by subtracting 4x from both sides. Giving me 12y equals negative 4x plus 140. And then dividing both sides by 12, meaning I need to divide every term in the equation by 12. That'll give me y equals negative 4 divided by 12 is negative 1/3 when simplified. X plus 11.6 repeating. And there's where the problem is. My slope is a very nice, usable negative 1/3. But my y-intercept, 0, 11.6 repeating, is not going to be very convenient to graph on my xy axis. So I can do one of two things. I can try typing y equals negative 1/3 x plus 11.6 repeating into the y equals on my calculator, my TI-84, but the repeating decimal may still give me some problems. So what I think I'm going to do is find a different point to start from rather than the y-intercept. And if I look carefully at the original equation, I think I can use the x-intercept. So remember, when using the x-intercept, make your y-coordinate 0. So I'm going to ignore the 12y, because 12 times 0 is 0. And I will have 4x equals 140 dividing both sides by 4, I get x equals 35. And that is a very good starting point. So start from your x-intercept when you have to, rather than your y-intercept. So if I start from 35, 0, I don't want to go down 1 to the right 3, even though that's the slope, because that will give me a negative number of adult tickets. So I'm going to go up 1 to the left 3, 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 and I'll connect those with a line. Remember, don't arrow that line, because then you'll get into the negative number of adult tickets, the negative number of children tickets, which you don't want. Now I'm going to solve the other equation for y, and this one will work out to be a little bit easier because when I subtract x from both sides to solve for y, I get y equals negative x plus 15. Not only is my slope very convenient, negative 1, but my y-intercept, 0, 15, works very well on the graph. And I also have an x-intercept. Again, if I ignore the y, I get x equals 15. So 15, 0. I have quite a few usable points here. So I'll use the x and y intercepts. Here's the y-intercept. Here's the x-intercept. Remember to label x plus y equals 15. I'll use my original equation. And my point of intersection is 5, 10. If you remember, x represented the number of children's tickets, so there are 5 child tickets. And y was the number of adult tickets, so that would make it 10 adult tickets. Here is the answer to the question. How many child tickets, how many adult tickets were bought? 5 child tickets, 5 adult tickets. So that was 5 child tickets, 10 adult tickets. So can we use an algebraic method? Would that be easier? I think it would be. So I'm going to use a method called elimination here, where I would eliminate either the x or the y and end up with one equation, one variable, and solve. And in this case, I'm going to attempt to eliminate the x's, simply because there's less of them. So if I take my second equation, x plus y equals 15, and multiply through by negative 4, I would end up, remember you have to distribute the negative 4 to all 3 terms, with negative 4x minus 4y equals negative 60. Now, why did I do that, you may ask? Because if you look at the first equation, I had an x term with a coefficient of positive 4. When I add these two equations together, now I'll simply copy over the first equation so that they're on top of each other. If I add these two equations together, these x's will cancel out. They're additive inverses. I'll be left with 8y equals 80 dividing both sides by 8, y equals 10. And that, if you remember, was my number of adult tickets. So once again, there are 10 adult tickets. Now to get my number of child tickets, I'm going to rewrite the second equation, again, simply because it's easier. X plus y equals 15. No coefficients to deal with the x's and the y's. I'm going to substitute 10 for y, since I know that y is 10. And I'll have x plus 10 equals 15. Subtract 10 from both sides, I'll get x equals 5. If you remember, x was the number of child tickets, so there are now 5 child tickets. Same answer, seems to be a little bit easier to solve using algebra. I can also check to make sure this is correct. If I have $4 child tickets and there are 5 children's tickets, that's 5 times 4, which is $20, plus $12 for adult tickets, and there are 10 of them. That's 12 times 10, or 120. That gives you a total amount of money, $140. That checks. Since there's 5 children and 10 adults, that adds up to 15 total tickets, and that checks with the words. So there's your 2 methods of solving real-world linear systems of equations: algebraic and graphically. This is Mrs. Lindsay. Have a great night. See you in the morning.